Take a closer look at the new M-Finity industrial circular saw blades from the Morse company, engineered to power through steel, ferrous metals, and more with speed and clean-cut precision. Built for demanding production work, M-Finity blades deliver dependable cutting performance across solids and tubing in carbon steel, cast iron, stainless steel, alloy steels, bearing steels, and tool steels. The thin kerf design with chip breakers reduces gullet clogging and supports cooler, longer-running cuts. The M-Finity coated option adds a temperature-resistant treatment that boosts productivity and extends blade life in challenging materials like stainless steel. From steel service centers to forging shops and specialized manufacturers, these blades minimize downtime and perform especially well in repetitive cutting environments, making them a strong fit for automotive suppliers, heavy equipment manufacturers, pipe and tube mills, and gear and bearing manufacturers. With sizes ranging from 250 mm to 630 mm, M-Finity offers the flexibility to fit a broad range of popular machines, including Tsune, Nishiji Max, Amada, and more. Available in multiple tooth counts, bores, and pinhole patterns, the product line was built to make blade selection and machine compatibility easier. M-Finity coated is available in common sizes from 360 mm to 630 mm and is designed for high production performance in tougher cutting applications. When selecting a blade, the details matter just as much as the saw itself. The pinhole pattern and bore are what allow the blade to mount properly and run without interference, so these dimensions must match the machine exactly. The pinhole pattern is defined by 3 numbers. The first tells you how many holes are in the pattern. The second specifies the pin diameter, and the third gives the diameter of the circle the holes sit on. That second dimension is especially important. It must be equal to or larger than the saw's drive pin diameter, and if the hole is oversized, the blade should be pre-loaded to reduce the risk of movement or failure. Blade diameter is set by the saw manufacturer, so always verify compatibility before installation. Tooth count should be chosen based on the tooth selection chart we will see later in the presentation, since it directly affects cut quality and performance. Kerf is the width of the cut, and in M-Finity's case, the thin kerf design removes less material and requires less power than a standard blade. Now we will show you how to properly pre-load an industrial circular saw blade to ensure the best cutting results. Pre-loading a circular saw blade on a machine helps ensure the blade doesn't slip, vibrate, or fail prematurely, especially if the blade pinhole diameter is larger than the specification of the machine you are running on. There can be a lot of movement between the drive pins and the pinholes on the blade. Pre-loading prevents the blade from shifting when entering a cut. To properly install and preload the blade, put the blade on the machine ensuring the bushing is clear of debris. Install the outer hub and tighten the bolt until there is some resistance, but the blade can still move back and forth. Then clock the blade in the reverse direction of the cut and tighten the flange. This is how the blade will cut with proper preloading. As the teeth enter the material, the force from the cut is properly transferred to the drive pins with no backlash. This is what can happen if you don't properly preload the blade. The blade will have backlash as it enters the cut, damaging the teeth and causing catastrophic failure. This chart helps you select the best M-Finity blade based on diameter and tooth count, so you can cut the right cross-sections with confidence. Using the correct blade size for the job is critical, because stepping outside the recommended range can cause tooth strippage, gullet clogging, and premature wear. This reference data is a helpful starting point for determining the right RPM and chip load for a wide range of materials. To choose the proper blade size, focus on the materials being cut most often and the production demands of the job. M-Finity is designed to perform reliably across most preset saw settings, making setup easier and helping operators get to work faster. Now, let's learn about some common problems saw operators may encounter in the field and what you can do to find solutions to keep productivity high. Tooth stripping in industrial circular saw blades is typically the result of excessive mechanical or thermal loading on the cutting edges, most often driven by inadequate chip evacuation and system instability. Chip jamming increases cutting resistance and heat, placing abnormal stress on the teeth, while insufficient machine torque, worn transmission components, or lack of rigidity can amplify vibration and load inconsistency. Additional contributing factors include improper material clamping, blade misinstallation, and incorrect tooth pitch selection relative to material diameter and composition. Corrective action should follow a systematic inspection. First, verify chip evacuation by adjusting or replacing the chip brush and optimizing cutting parameters. Next, inspect the machine drive system, including transmission belts and gearbox components, for wear or slippage. Confirm the clamping system is secure and the workpiece is properly supported and free from deformation. Re-clean all mounting surfaces and reinstall the blade according to manufacturer specifications to ensure proper alignment. Finally, validate that the blade tooth count and geometry are appropriate for the application, and adjust cutting parameters to match the material characteristics. Proper system alignment and parameter control are critical to ensuring consistent blade performance. A rough, uneven cut surface is often the first sign that something's gone wrong in your sawing process, and it's usually tied to issues like gullet clogging, chip welding, or blades running out of square. These problems typically stem from poor chip evacuation, worn or improperly aligned components, or even something as simple as insufficient coolant. When chips aren't cleared effectively, they jam the blade, overheat the cut, and compromise finish quality. The fix starts with optimizing chip removal by adjusting your chip brush and dialing in the right RPM and chip load. From there, inspect your setup. Ensure flanges are true, guide blocks are properly aligned, and blade teeth are free from damage. A thorough cleaning and correct blade installation can make a big difference. But don't overlook coolant. Boosting flow and correcting nozzle direction often restores cutting performance quickly. Addressing these factors systematically not only improves surface finish, but also extends blade life and keeps your operation running smoothly. A wavy surface finish is a clear indicator of instability in the cutting process, often accompanied by abnormal noise during operation. This condition is typically driven by insufficient cooling, incorrect sawing parameters, or improper tooth selection, all of which can disrupt cutting consistency and introduce vibration. Inadequate coolant flow allows heat to build at the cutting edge, reducing blade stability and accelerating wear, while mismatched RPM can cause the blade to deflect or chatter. Similarly, using a blade with an incorrect tooth count for the material diameter can lead to uneven chip load distribution and inconsistent cutting forces. To correct this issue, first verify that coolant delivery is sufficient. Adjust flow rate and ensure the nozzle is properly aligned to the cutting zone. Next, optimize sawing parameters based on the material's properties to maintain stable cutting conditions. Finally, confirm that the blade's tooth count is appropriate for the application, ensuring balanced engagement and smooth chip formation. Addressing these factors will restore cut quality, reduce noise, and improve overall process stability. Thank you for taking time to learn more about M-Finity industrial circular saw blades from the Morse company. Since 1963, we have remained dedicated to creating innovative cutting solutions and delivering industry-leading delivery times, customer service, and technical support. We are more than a manufacturer. We are your partner in always striving for a better way to cut.